Welcome to this lesson 5-1. This is finding the restricted domain of a square root function. And in this video, we are laying down the groundwork for just being able to identify what is the domain values specifically for square root functions, okay? And the problem with square root functions is that they output imaginary values if the domain of the radicand is, or the input of the radicand is negative. Okay, so we have to restrict those domains. This is very valuable for this unit as well as moving on into calculus. So without further ado, let's go ahead and look at some examples. And here the concept says that the domain of a square root function is determined by making the radicand non-negative. So whatever the radicand is, we set it greater than or equal to 0 and we solve for x. Okay, now this is necessary, right? So our outputs are real values and not imaginary values. Okay, so here is our first example. And it says, find the domain of the square root function without using a graph. Use set and interval notation. So again, the very, very first thing that we want to do is we want to take our radicand and set our radicand equal to 0. So set radicand equal to 0. Sorry, greater than or equal to 0. So I'm going to take the radicand, okay, which in this case, 5x minus 3. Don't care about anything else, okay, 5x minus 3, and I set it greater than or equal to 0. Next, we'll solve. 5x is greater than or equal to positive 3, which means that x must be greater than or equal to 3/5. Okay? So, if my x values must be greater than or equal to 3/5, I want to go ahead and write this on a number line. So here's 3/5. I want all the values equal to 3/5 and greater going this way. Okay, so that is positive infinity. Okay, so how am I going to write that in set and interval notation? Okay, so here is set notation. It's all the x values such that x is greater than or equal to 3/5. Okay, interval notation. I want it to be 3/5 to infinity. Now, what are the notations that go on the ends? Well, 3/5, I want to include that value, and then infinity, we never include. Okay, so there is your domain. In example 2, we have the same type of function, okay? I have the function g of x, which has a radicand of -1/2 times x plus 2, and actually that plus 1's on the outside, so we don't care about that. Okay, so I'm going to take my radicand, -1/2 times x plus 2, and I set it greater than or equal to 0. Now, I'm going to go ahead and multiply this side by -2 to get rid of the 1/2. I'll multiply by -2. And remember, when you multiply or divide by negative with inequalities, what happens to the sign? It switches. Okay, so there we go. Still 0, but we got to switch the sign. Okay, so x plus 2 must be less than or equal to 0. Okay, which when we subtract 2, we get x is less than or equal to -2. Okay, so on our number line, here's -2. Okay, I want all the values equal to or less. That goes this way. Okay, and that's going towards negative infinity. So our domain is negative infinity to -2. Include the -2. Okay, and then in set notation, it's all the x values such that x is less than or equal to -2. All right. Okay. What we're going to look at now are quadratic examples, and you'll notice here that the quadratic has a square in it. Okay, and this is going to do something kind of funny. I'm going to take my radicand, x squared minus 12, and I know I want it to be greater than or equal to 0. But when I solve this, I'm going to switch this out to be an equal sign, equal to 0. And I'll show you why here in a second. Okay, what I'm getting is critical values. So x squared must be equal to 12, which means that x is equal to plus or minus square root of 12, which is plus or minus 2 root 3. Okay, so I solve this, right? And initially we said we want these values to be greater. I switch over to an equal sign because it doesn't make much sense if we have x is greater than or equal to plus 2 root 3 and negative 2 root 3. We get a weird situation. Okay, I'm going to draw a number line. You should draw a number line as well. So here's negative 2 root 3. Here's positive 2 root 3. Okay, and if I said I want all my values to be greater than or equal to both these values, we get kind of an overlapping area or a contradiction. So what we're going to do, we have found our critical numbers. Right there. Okay, and what we're going to do is we're going to test. We're going to do what is called sign analysis. Sign analysis. Okay, and all we do with sign analysis is I want to figure out, do I get values that are positive or do I get values that are negative on these intervals? And we're going to test some intervals. Okay, so I'm going to go ahead, I'm going to take 0 here. Okay, and when I plug 0 into my original inequality, I want to say, okay, does it give me a positive or sorry, a true or a false statement? So when I plug in 0, we get negative 12 is greater than or equal to 0. Now this is false, not true. Okay, false. So that means the numbers in this area, okay, are not greater than 0. Okay, I'm going to put an X here. All right. Now, all my values in this section, right, are negative. Okay, that means if you're familiar with parabolas, what we have here is a parabola that is down 12. I have a vertex centered at negative 12, okay, and I have values that are coming up this way, and they come up here. Okay, so our domain are on the outsides of this. Okay, and if you want to double check, you can just take numbers over here, such as 4, negative 4. They're both going to give you the same value. So I plug in 4 squared, that's 16. Okay, 16 minus 12, is that greater than or equal to 0? And you bet you that it is. Okay, same with negative 4. Okay, so these are your two solution regions. Okay, so how do I represent this for our answer or our solution? Okay, so domain is, okay, negative infinity to negative 4. Okay, I'm going to include negative 4, union, and then I also want to go from 4 to positive infinity. And if you're like, Schwarberg, where are you getting this? Okay, I'm getting this from, trying to erase right here. It's not letting me erase. I'm getting this from this section here. Okay, there we go. Okay, so I'm getting it from this section. So from 4 this way, and from 2 root 3 this way to 2 root 3 this way. Okay, just this area in between is not part of our domain. All right, so, oh, you know what? It's not 4. It's 2 root 3. 2 root 3. Negative. Positive 2 root 3. Okay, and then as set notation, it is x such that x is less than or equal to negative 2 root 3, or x is greater than or equal to 2 root 3. Okay, and here is your answer. All right. Next example. In this example, we have 49 minus x squared. And we want this to be greater than or equal to 0. Okay, so I want to go ahead and solve this. 49 minus x squared is equal to 0. Okay, and when I do this, we get 49 is equal to x squared, which means if I just use the reflexive property, that x is equal to plus or minus 7. So again, these are our critical values. Okay, and over here I have negative 7. Over here I have positive 7. And I'm going to go ahead and I want to test. So I'm going to test 0. Okay, now when I plug in 0, we get 49 minus 0 is greater than or equal to 0. This is true. Okay, so that means in this region from negative 7 to 7, this is my domain. Now you can test it if I plug in values outside. I don't know, maybe try values such as, we'll go with 10. Okay, if I plug in 10, we get 49 minus 10 squared, which is 100, and this clearly is not a positive value, false. Okay, so those values fail. Okay, so what is our domain? Well, our domain is the region from negative 7 to 7. Okay, and I include those values. If I plug in negative 7, I get 0. That's okay. I can have a square root of 0, right? That's non-imaginary. That's real. And then as far as set notation, the x values such that negative 7 is less than or equal to x, which is less than or equal to 7. Okay, there's your domain. All right, very, very last example for this video. Here is a trinomial. And I know this seems complicated, but again, we're going to take our radicand, x squared minus 5x plus 4, and we set it greater than or equal to 0. Okay, and I want to find the critical numbers for where it does equal 0. So what we do is we just set it equal to 0. And what I'll do is I'll factor this. This is x minus 4, x minus 1. Okay, which means we get x is equal to, x minus 4 is equal to 0. X minus 1 is equal to 0, which means that x is equal to 4 or x is equal to 1. So here's our critical numbers. Okay, 1, 4, and I want to pick a number in between these two to test. I mean, you can also test 0, and what you'll find, here's two cases. Here's the two situations. You will get, whoa, skipped around. Okay, you will get pass, fail, pass. You'll get this situation, or you'll get fail, pass. It's supposed to be green, fail out here. Okay, you'll get one of these two situations every single time for square roots. Okay, so you really only have to test one interval. Okay, so I mean 0 is the easiest, but I'll make it a little bit more complicated. I'll test 2. I like testing in between. I don't know why. Okay, so we get 2 squared. That's 4 minus 5 times 2. That's 10. So 4 minus 10. Okay, plus 4. All right, and is this greater than or equal to 0? And the answer is false. It is not. So this region's not part of our solution set. So that means our domain is x values less than 1 and x values greater than 4. Okay, so here we have it, domain. Okay, I want to go from negative infinity to 1. Union 4 to positive infinity. Okay, and for set notation, x values such that x is less than or equal to 1, or x is greater than or equal to 4. All right, so there you have it. That's it for this video on solving square root, the domain of square roots. And what I'm gonna do right now, I have practice problems. Okay, so you can look at these problems, you can pause, and then you can attempt them. All right, so go ahead and look at these practice problems. Okay, and here is the solution. All right, here's the next practice problem. Please pause the video and attempt this one. Okay, here is the solution. There you go. All right, the next practice problem is here. Please pause the video and attempt this one. Okay, and last but not least, here is the last practice problem. And please attempt this one. Okay, that's it for this video. I'll catch you next time. Peace out.